Question 11. This question is of differentiation. The equation of the curve is such that dy over dx is equal to 6x square minus 30x plus 6a, where a is a positive constant. The curve has a stationary point at a minus 15. This is the stationary point on the curve, and this is the gradient expression. Find the value of a. Now dy over dx is given. Dy over dx gradient expression is given, that is 6x square minus 30x plus 6a. Now we know that for stationary point gradient will be 0. So we can write here dy over dx is equal to 0. When we will put this dy over dx is equal to 0, we get 6x square minus 30x plus 6a is equal to 0. Now the point stationary point is given, that is coordinates are a minus 15. Putting here the value of x, point is given stationary point a minus 15. Now this is the value of x, this is the value of y. Putting here the value of x, a is the value of x. So this equation becomes 6a square minus 30a plus 6a is equal to 0. Simplifying it, minus 30a plus 6a, that is minus 24a. So 6a square minus 24a is equal to 0. Taking 6a as a common, 6a into a minus 4 is equal to 0. This shows that 6a, either 6a is equal to 0, from here a is equal to 0, and either or a minus 4 is equal to 0, from here a is equal to 4. But which value we have to taken, it depends upon the question statement. It is written that a is a positive constant, so we are not taking a is equal to 0, so this is not valid. So only the answer is a is equal to 4. This is the answer, this is the value of a. Now part B of this question is determine the nature of the stationary point. Nature of the stationary point means if this point, stationary point, is maximum or minimum. For this we have to take the double derivative of this. Single derivative is dy over dx is given, that is 6x square minus 30x plus 24. This 24, because we have put this value of a here, 6a mean the value of a is 4, so this term become at 24. So gradient expression, first derivative will be 6x square minus 30x plus 24. Taking double derivative, we are again differentiating with respect to x. We get d square y over dx square 12x minus 30. Now we will put this point, stationary point. X coordinate of the stationary point is a. A we have found, that is 4. So putting this point 4 minus 15 is the stationary point. Putting the value of ax here, we will check the sign of double derivative, that is d square y over dx square 12 into 4 minus 30, that is 18. Clearly 18 is positive. So we get double derivative is positive. So this point is a minimum point. Hence the given stationary point. Hence this point 4 minus 15, that is stationary point. It will be minimum because the value of double derivative is positive. Next part C of this question is find the equation of the curve. When the gradient expression is given, since the gradient expression is given, we have to find the equation of the curve. So this part is a part of integration. When the gradient expression is given, we have to find the equation of the curve. We will integrate each side. So first we write here the gradient expression dy over dx, that is equal to 6x square minus 30x plus 24. Now we will integrate each side. Before integration, we uh, are rearranging by cross multiplying. We can write it as separating the variables. Dy will be in the left hand side, 6x square minus 30x plus 24, or dx will be here. Now we will integrate each side with the corresponding variables. On the left hand side there is no function. On the right hand side the function is this expression. Dx means we will differentiate, we will integrate this expression with respect to x. In the left hand side dy shows that with respect to y, but there is no function. We are taking here 1 as a function. We will write here 1. No, integration of 1 with respect to y will be y. So we are writing here y. On the right hand side we will integrate each term separately. We get here 6x3 over 3 minus 30 x square over 2 plus 24x plus c. This c is the constant of integration. So simplifying it, we get y is equal to 2x cube minus 15 x square plus 24x plus c. Now we will find the value of this constant of integration, which is represented by c. So putting here, actually this is the equation of the curve. This is the equation of the curve. Just we have to find the value of this constant c. Since this point, stationary point is given 4 minus 15, this point lies on this curve. So we are putting this point 4 minus 15. We are putting this point on this equation of the curve. We get value of y is negative 15, x is 4. So minus 15 is equal to 2 into 4 cube minus 15 4 square plus 24 into 4 plus c. Simplifying we get minus 15 is equal to 128 minus 240 plus 96 plus c. So we get the value of c from here, that is 1. So now equation of the curve will be, now putting here the value of c, this is the equation of the curve, but we will put this value of c here. Equation of curve will be, equation of curve will be y is equal to 2x cube minus 15x square plus 24x plus 1. This is the required equation of the curve. Now the next part, the last part of this question is part D. Find the coordinates of any other stationary points on the curve. Find the coordinates of any other stationary point on the curve. One stationary point is given, that is coordinates are 4 minus 15. Now find the coordinates of any other stationary points on the curve. So for stationary point gradient is 0, we know very well. dy over dx for stationary point is 0. So putting here gradient is equal to 0, first derivative we have already, it is given. First derivative is this 6x square minus 30x plus 24, that is equal to 0. First derivative is given 6x square minus 30x plus 24 is equal to 0. Since in this expression all the terms are the multiple of 6, we can divide by uh, 6 each side, because 6 is a multiple, all the terms are the multiple of 6, so we can write dividing each side by 6, we can get x square minus 5x plus 4 is equal to 0. Now we factorize this quadratic equation, x square minus 4x minus x plus 4 is equal to 0, taking x common, x minus 4 minus 1 into x minus 4. So there are two factors, x minus 1, x minus 4 is equal to 0. So we get the two values of x from here, x is equal to 1 or x is equal to 4. Clearly this 4 is already given, this because this is the coordinate of the first stationary point. The other stationary point will be at x is equal to 1. So x is equal to 1, 1 is the x coordinate of the other stationary point. Now also we have to find the y coordinate of this point, of this stationary point when where x is equal to 1. Other stationary point is x is equal to 1. Now we will find the y coordinate when x is equal to 1. So putting here, putting this x is equal to 1 in the equation of the curve. Equation of the curve is we have found in part C. So equation of the curve is y is equal to 2x3 minus 15x square plus 24x plus 1. Putting this value of x is equal to 1 here, so we get y is equal to 2 minus 15 plus 24 plus 1, and this shows that y is equal to 12. So the other stationary point will be, other stationary point will be, x coordinate is 1 and y coordinate is 12. So other stationary point will be 1, 12. This is the answer. 1, 12 is the other stationary point on the curve.